Okay, hi everybody. Thanks for coming. So my name is Guy, as you've just seen, and today we're going to see an alternative way of using Docker containers. I work as a solution architect for Codefresh, and you have my email here if you want to ping me for any questions about this talk. By the way, we created a Git repo for this talk with all the demos. So if you want this, again, just ping me after the talk and I can send it to you. So to quickly go over the agenda, we're going to see, as I mentioned, an alternative way of using Docker containers, not as deployment artifacts, but as build tooling, and then see how this new approach can help us in upgrading tools to new versions and maintaining multiple versions of the same tool without any problem. And we're going to have demos for these things as well. So let's start with the theory. When people say, most people, when they say that they're using Docker in production, what they usually mean is that they are taking the final package, putting it in a Docker image, and this is what they deploy. This is what you see here on the top. This is not what I'm going to talk about today. Today we're going to focus on a different thing, which is using Docker for build tooling, which is not mostly what people think. So just to very quickly describe the CI/CD processes, I guess that most of you are familiar with. So CI, right, we'll start from checking out our code, compiling it, running some tests, build, and then moving over to the CD part, the continuous deployment. So this life cycle back before containers, what I refer to as the dark ages, was very difficult for both developers and operators, but especially for operators because they literally had to know everything. Operators in organizations that use multiple programming languages, multiple tools, had to know how Java applications are deployed, how Node applications are deployed, how Python applications are deployed, and this was very challenging for operators. So when using Docker as a deployment artifact, what you can see here on the right, this made the life of the operators much easier because now they don't really have to care about what programming language is being used. They just get the Docker image, and this is what they deploy. And this also gives a common language between the developers and the operators. So this makes the life of the operators much easier. Again, this is not what I'm going to focus on today's talk. What I am going to focus on today's talk is taking this another step and Dockerizing not only the deployment artifact, but also the steps inside the pipeline, the CI and CD pipeline. So what you see here in the middle. And we'll see how this new approach can help us with the things that I mentioned at the beginning. So to compare the old versus the new, as I guess that most of you are familiar with traditional VM-based CI and CD platforms, this is what you can see on the top. So what we usually had is a build node, which is based in a virtual machine. And then this build node had to contain all the tools that developers in my organization want to use. So let's say some of my teams, they use Node. I have to have Node, let's say version 9, installed on the build node. I had to have Java and Go, and everything that I need had to be installed on the VM. And the new approach, what you see on the bottom here, is what I refer to as Docker-based pipelines, which means that the build node itself only has Docker installed and nothing else. And then the developers, when they create their pipelines are running as Docker images that contains only the tools that they need. So again, Docker as a deployment artifact is a very important topic as itself, and we actually have a lot of information about it on our blog and webinars that you're welcome to check out. But again, we're going to focus on the CI/CD pipelines scope in this talk. So imagine you have you're working in a large organization, and for your CI/CD processes, you have build nodes, and in large organizations, you're usually going to have many build nodes, so you can refer to this as a build farm. And again, as we mentioned, each of these nodes, in the simplest way, had to have all the tools that you're using in your organization installed on. And again, the simple way was that you have identical nodes, and you have every tool that you use installed on each of the nodes. But sometimes, especially when you start using multiple tools, this can get quite difficult to maintain. And then what operators would do is they label different build nodes. So for example, this build node has Java 9 installed on, and it has Python 3.7. And then there's another node that has different versions. And then the job not only of the operator is difficult because it has to maintain these different type of nodes. Also, the developer, when he wants to run his pipeline, he has to choose the correct build node, because if the developer wants to build his application that needs Python 3.7, he has to choose a specific build node that has this version installed. With the new approach, this is much easier because both for developers and operators, because we have identical nodes, and each of the nodes has only Docker installed. So for the operators, very easy to maintain, just one tool to install. All the nodes are identical. And obviously, this is easier for the developers because they don't need to choose a specific node. They don't care about that because every node is the same. They're all identical, and their pipeline will work exactly the same on all the nodes. So the way that it will look like is, again, every node will have only Docker installed. And then when a developer brings his pipeline, he will use Docker images inside his pipeline with only the tools that he needs. So for example, he wants to use Terraform, he wants to use a node, he wants to communicate with AWS CLI. He will only have these tools in his pipeline. He will run his pipeline on any of the build nodes. And once the pipeline is finished, then all these Docker images, all these tools are discarded, and the node reverts back to its original state. So it doesn't really change the build nodes. This is also easy because these days, as we all know, Docker is everywhere. Most people know how to build Docker images. They know how to store them and use them. And you also have public Docker registries like Docker Hub, where you can find a lot of images that were already created for you. So let's say you want to use Terraform, and you want to use Terraform inside a Docker image. You don't have to go and create a new Docker image. There is already one created. You can find it in Docker Hub, for example. And if you want to use your own private Docker images only for your organization, then you can just create a registry, private registry for your organization. So how will this look like? Let's take another step deep inside and look at an example of a pipeline. So with this new approach, as I said, every step in the pipeline will run a Docker image. So let's say I have a node application, and in the first step, I want to install the dependencies, download the modules, the node modules. Then for this step, I can use the node 9 Docker image, the official Docker image for this that already has node running on it. For the second step, let's say I want to store some test artifacts in my S3 bucket in AWS. I can use an image that has the AWS CLI running on. And last, maybe I want to use Helm to push my chart. Then I can find an image that has Helm installed on. And we're going to see demos and see how this running in action. So for today's demos, we're going to use Codefresh. Codefresh is the first CI/CD platform built for Kubernetes, and Codefresh follows this approach of running pipelines. And it also has a lot of other cool features like built-in Helm deployments and dashboards. But today we're not going to focus on them. We're going to focus more on how to build pipelines and with this new approach of Docker-based pipelines. So let's start with the first example. Let's say I have two microservices, one with Python, one with Node. And again, this is the public Git repo that I'll share with you later on. So I'll click on the first project, and I see my two microservices. Now, let's open Codefresh and see how a pipeline would look like for this for these two microservices. So in Codefresh, we use a declarative YAML to build our pipelines, and this is how it will look like. So in this pipeline, we have two steps, right? The first step will package my Node application, and all I have to specify is the image that I'm going to use. So this is a Docker image that has Node 11 running on. Then I can run any commands that I want. So here I'm going to print the version of Node running on this container. And the second step will do the same for my Python application. So again, it's going to use the Python 3.6 Docker image and then print the version and package it. So let's see how the pipeline will look like. And this is how it will look like. And now I can just click on each of these steps. I see that on the first step, I have Node 11 running. And on the second step, again, packaging my Python application, I have Python 3.6 running. So it's that easy. I didn't need to install Python or Node on the actual build node. I can just use the Docker image that has these tools running on it. Now let's talk about some problems of traditional VM-based CI and CD platforms. So let's say I have this project now that we just saw, and it's running these two microservices, one with Node and one with Python. But now I want to also use AWS CLI in my pipeline, or I want to use Terraform. So in traditional VM-based CI/CD platforms, what I have to do is I have to open a ticket and tell my operator, hey, I need to use AWS CLI. Then my operator has to see this ticket. Then he has to look for AWS CLI, see how to install it on my build node. Then maybe a few days already passed, maybe a week, and then he comes back to me and says, okay, now you can use AWS CLI or Terraform. So with this approach, developers, obviously they would ask, what tools does your platform support? Like, do you support Node or Java? Do you support Ansible? And because they're used to asking their operator to add tools and open tickets, and this is a real problem. Like, this is a screenshot of a real VM-based CI/CD platform where you see tickets that real users opened. Like, for example, we have a user that wants to use Python 3.7, and he can't because it's not installed on the node, and he has to open a ticket for that. And on the right side, we see the changelog of this company, and we see adding support for more tools and more versions. With container-based pipelines, we don't have to worry about that. So now let's extend our previous example and add Go and AWS CLI to our pipeline. So now looking at my Git repo, I see that I added a Go microservices here. And let's look at what changes I had to make in order to add this Go step. So we'll look at the pipeline again, and I see that all I had to do is add another step, and this time simply specify the image as the official Go image, in this case, version 1.7.1, and then I can package my Go application that easy. Now let's say I want to run AWS CLI to communicate with AWS. I simply provide the Docker image, the official Docker image of Mesosphere that has AWS CLI running on it, and use it. And you see commented out, I also have an example with using Terraform. So again, I don't need to install anything on the node. I just add any tools that I want by simply specifying the Docker images for these tools. And if we look at the pipeline for this pipeline, see the visual for this pipeline. Again, I have my node application, which we previously saw. I have my Python application. And now I also have Go, packaging my Go application. I see the Go version. And finally, deploying or communicating with my AWS account. And I see it running here. So that was adding additional tools to my pipeline. And I think that by now you understand that the questions of what tools we support, do we support Node 10 or we support Python 2? The question is yes to all of these. The answer is yes to all of these questions because every tool that has a Docker image or that can be easily packaged in a Docker image, we automatically support it. And the cool thing about this is that it's also future-proof. So let's say tomorrow a new version of Python is released, or a new tool is released, and you want to use this tool in your pipeline, you don't have to wait for the platform to add support for this tool. You don't have to open a ticket to your operator to install this new tool on the build node. You can automatically just find a Docker image that uses this tool and use it in your pipeline with no problem. So now let's see another classic problem of CI/CD platform with VM-based platform of upgrading a tool. So let's say I have my build node and it already has, let's say, Java 5 installed on. But now I created a new application that is using Java 9, and I want to use Java 9 in my pipeline. So for that, again, I'll need to open a ticket to my operator and say, hey, I want to upgrade to Java 9 because I need it for my new application. And this will be challenging for the operator because then first it has to compare the two versions and it has to see how to install Java 9. But now he also has to make a decision and decide, should I keep the old version or maybe I can just remove it? Same thing for Node or Python or any other programming language. And again, this is a screenshot from a real VM-based platform. And you see tickets of users like, can you add support for PHP 7.3? Because you can't just use it immediately, you have to add support for it. On the right-hand side, you see the opposite problem. Like you see old versions of R are no longer available. So let's say the operator upgraded the version of R on my build node, but he removed the old version. And now I simply can't run my application anymore if it's using the old version. So that's a problem. And let's see how easy it is to update to, let's say, Python 3.7 using the new concept. So I can look at the same example, actually. We can go to the pipeline and see. So you see, now I'm running this, packaging this application using the Docker image for Python 3.6. I want to upgrade to Python 3.7. All I have to do is comment this line and then use this line instead to point to the new Docker image that has Python 3.7 installed. And if we look at the pipeline, we see that that was the only change. don't have to open any ticket to an operator, and then he doesn't have to remove an old version or then figure out how to maintain two versions of the same tool on the same build node, which is also a problem. So very easy for upgrades. Now we actually just discussed these things of using tools of different versions. And for that thing, a new family of software was actually created, which is version managers, as you know. So you see some examples here on the screen. For example, a version manager for Ruby, or for Node, or for Python. And this solution is kind of funny because you now have to maintain a new piece of software, right? The version manager, just to solve a problem that shouldn't exist in the first place. So this is just a waste of time for the operators and also for the developers. So let's say now I'm a developer. I have a build node, and my operator installed both Python 2.7 and Python 3.6 on the same build node. If it's using a version manager, now I have to first run the version manager with some parameter and make it run with my preferred version. But let's say a new version of Python is now released. You don't need to update only the Python version on the build node. You also have to update the version of the version manager because it will not automatically support new versions. So again, we can just eliminate this whole problem at the first place by using containers. Specifically Python. Python is a classic example because the latest version of Python is now 3.x, but there are a lot of legacy applications still running on Python 2. And this is a screenshot of a platform that is also VM-based, and these are all the Python versions that it's claiming to support. And now, let's say a new version will come out, let's say 3.8. Then you will have to wait for them to add support to it. And also, there's the opposite problem. So let's say, what about Python 2.5? They decided to not support it anymore. So if I have an application using Python 2.5, I simply can't use it. Now, what we did is replaced version manager with Docker. And that's a much easier solution because Docker is not dependent on specific programming languages or specific versions of programming languages. It runs with any programming language. Docker is already installed on the build node, so it's much easier in terms of maintenance. And you can use, as we mentioned at the beginning, both public and private Docker registries in your pipeline. So with this approach, we support every container ever made and every container that will ever be created. So let's say a new version of Python is now released. You want to use it, you simply specify the Docker image name that has the new version. Don't need to wait for any operator or any change. Now again, we can simply look at the same example as before and see that in this pipeline, we ran two different versions of Node. So the first step here is using Node 11. The second step is using Node 9. This step of packaging my Python application is using Python 3.7. And the step that is communicating with AWS, if you look here, you see it's using Python 2.7. So no need for version managers, no need to find out a difficult way to maintain both versions of the same tool on the build node. Just point to the Docker image that you want and use any tool that you want with any version. Now, you can say, okay, but obviously with every approach, there are challenges. On VM-based platforms, when you have all the tools pre-installed on the build node, the pipelines will run faster, right? What will we do here? How will we share data between steps? How will we use caching? So for data sharing, first let's discuss some use cases. Why do we need data sharing? So a classic example is, let's say you run a test on one step in the pipeline, and on the next step, you want to collect the test results, the artifacts, and maybe you want to generate a report, or you want to store the artifact somewhere. Or let's say you have, again, a node application. You want to download the node modules at the first step, and then be able to use them in the next steps without downloading again the node modules every step, because this will just take a lot of time. So the way that this was done with VM-based platforms was you have to make some specific special settings for directives, usually in the form of cache or artifacts. And then as a developer, you had to decide before running the pipeline which folders you want to exist in the next steps. And for operators, this is also challenging because you have to know everything. You have to know where Python cache is stored. You have to know where Maven cache is stored in order to make sure that it passes on to the next step. With Codefresh, because we know that containers has volume support, what we do is we mount a dedicated volume for each pipeline, and then all the files are simply stored on the volume, and you have access to them in all of the steps. As well as the Git repo, all of the files from the Git repo are automatically stored on this volume as well. So you don't need to make any specific directive settings or cache configuration. All your files will be there in all of the steps. And then, again, if we think of the example of, on the first step, I want to run npm install, I want to download all my node modules. Then these node modules will be downloaded on the first step. They will be automatically saved to the volume. And on the next step, I'll have the volume, so I can just access and use these modules. Don't have to download them again. So let's see how this works. And here, created another project for that. Okay. Then again, that you can see it here. So let's look at the pipeline. And this is the YAML file for this pipeline. So you see on the first step, I'm downloading my dependencies. And I'm using Node. I'm running npm install. On the second step, I want to run some unit tests. And I want to make sure that my modules are already there. I don't want to download them again. So let's look at the build for this example. And I want to make sure that you notice a few things here. So first, on the last step of running my unit test, I see that my unit tests are running fine. I have access to my node modules. They're not being downloaded again. And if we take a closer look, we see that even the first step that was supposed to download the node modules, even in this step, the node modules are not being downloaded. Why? Because with this caching mechanism, the cache is not only used between steps, but also because the volume is dedicated for each pipeline, then if I run a pipeline once, the node modules will be downloaded in the first step. Then the next step I run this pipeline, the node modules will already be there. So they won't be, and they don't need to download it at all for the subsequent builds. And then you see that this whole pipeline took about 32 seconds to run. So it makes the pipelines very, very fast with this caching mechanism of between steps and between subsequent builds. Now, the last demo that I want to show you, last example, is creating Docker images on the fly, on demand. Why would we want to do that? So far, all the example that we've seen is was using pre-made Docker images, right? So I wanted to package my Node application. I provided the official Node 11 Docker image, for example, or same for Python. But sometimes I'll have a specific use case. Let's say I want to run some tests, and I want in the same step to run tests with few different testing frameworks like Mocha or Predator or stuff like that. And I couldn't find a Docker image that has all these test frameworks installed on. So what I can do is I can build a step, I can create a new Docker image in the first step. Then it will automatically be stored on the volume. Then I can use it in the following steps. So let's see an example of this. This is again the last example. So this is an application that I have, and I have a Docker file for this example. But I created another Docker file called dockerfile.testing. And you see that this Docker file is using from Node, but it's also installing some testing frameworks like Mocha and Jasmine and Protractor. And this will, I can use this Docker file to create a new Docker image. So how will this look like in a pipeline? Okay, if I look at the YAML file for this pipeline, I see that in the first step, I'm going to package my Node application, right? Run my npm install. Then on the next step, I call this step create test image. And here I'm going to point to this dockerfile.testing that I created. And in the last step, where I'm going to run my tests, right? You see that the image that I'm using is not a pre-made image. It's a variable that I took from the first step with that new image that was created. And here I'm going to run Mocha --version and Protractor --version to see that indeed all these test frameworks are running in this step. And looking at the result, so I see here I created my new Docker image from that Docker file that I showed you. And in the end, I see all these frameworks running on this step with this new Docker image that I just created on the first step. So this is how you can create dynamic Docker images as part of the pipeline. And you can think of the same thing for plugins. So think about traditional CI/CD platforms like Jenkins, for example. Let's say you want to develop a new plugin for Jenkins. You have to know a few things. First, you have to know Groovy, right, to develop a plugin for Jenkins. Then you also have to use the Jenkins API. So you have to know the Jenkins API as well. And this sometimes can be difficult to test and to install. While with Codefresh or similar tools, Docker, the plugins are simply Docker images, like we just saw. So all you have to need is just some Docker knowledge on how to use Docker, how to package tools inside a Docker file, and then create a plugin. And we actually have a free marketplace where we posted some plugins that you can use, and also some of the community shared their plugins there as well. So let's say for blue-green deployment, you can see that we have a plugin for that. We did all the hard work behind the scenes, and then you can use this plugin with no scripting, no code, no commands, just pass some environment variables, and they will run in this new Docker image, which is a plugin. So to summarize, what we saw here is an alternative way using Docker not as deployment artifacts, but as build tooling. Every step in the pipeline is running a Docker image. We saw how this can make upgrading of tools very easy, how this makes running multiple versions of the same tool inside the pipeline very, very easily, and also saw how we can dynamically create new steps in my pipeline from within the pipeline. Thank you very much.